Good afternoon. My name is Marcus Case, and today I'm going to be presenting you my Making for Innovation final project. So first, for our introduction, we're going to be going through the what, why, how, who, and where. So on the right, obviously, that is a DIY still. So that's the project that I decided to do, is I decided to make my own still. Why did I want to do it? I've toured a couple of distilleries, and I always thought it was a really fascinating process. And it's almost like an art, so it's something that I can constantly improve on, and I can always constantly be working on that still and tweaking it. So that's why I thought it would be a good idea to do this for my final project. So how did I do this? I watched a lot of YouTube videos, and then I went to Lowe's and I picked up a lot of piping and pretty much went from there. For the boiler, I just went online and I bought a cooking utensil, and everything else was pretty much just piping that was bought at Lowe's. So for the who, I asked a couple chemical engineers for input and for help, and also Jerry helped me out. I used the laser cutter for a piece of sheet metal, and where. So most of the project was actually just done at my own place. And like I said, I did have to use the metal cutter at the Innovation Studio for cutting a piece of sheet metal. So what is distillation? So the overall process, I'm just going to put it in layman's terms. So whatever you have, you'll put it in a boiler. It'll be some kind of liquid. You'll start to heat up that liquid. And as that liquid gets heated up and turns into a gas, it'll run through your distillery column, which is on the right here. It's that yellow stuff. And as your liquid runs through your distillery column, or as your gas runs through your distillery column, sorry, that will pretty much separate it out. So if you're using it for water, the water will turn into steam. It's a little bit more simple for water. The water will turn into steam, and it will separate from, if it was salt water, it would separate from salt. If there's any other harmful materials in there, it also separate from that. It's a little bit more interesting for alcohol. For alcohol, we'd start off with like a 10% batch. And since ethanol has a lower boiling temperature than water, the ethanol would start to boil first, and that'll flow through our distillation column. And as it goes through the distillation column, it'll start to separate out. And after you distill it, you're going to have a much higher alcohol percentage with the output once it goes through that condenser. So here's my still. So for the dimensions on my still, what I found online was about 2 inches is good for a diameter on a distillation column. So I found some piping, and I made mine 1.75 inches in diameter. And I did some research online to see what worked best for the ratio and for the height to diameter ratio. And I found that about 1:30 ratio is good. So with the materials that I could find at Lowe's, we ended up going with a height of 56 inches, which makes our ratio 1:32, so just slightly bigger than a 1:30 ratio. So I also did some research, and I looked into what would be the best internals for our distillation column. So there's 2 different kinds. You have a packed column, and then you would have trays as well inside your column. I decided to go with a packed column, although if you look at the picture right here, I did also put trays inside this column. I'll be getting to the wires that are flowing through it, but pretty much what the packing does is it creates more surface area for that gas to spread out among itself, and it'll just assist in the distillation process. This stuff really isn't needed for water distillation. It's more helpful for ethanol distillation or essential oil distillation. And also the trays are more helpful for higher operations, like more fluid flow, different kinds of fluid flow. A packed column is just more simple, and it's perfect for a DIY project. So for the coolant system, that's something that I added in just so we can possibly work on it later on. So right now it's not operational, but pretty much it's in both parts of that distillation column. If you can see in the first picture, so we have it on both sides. You can see one a little bit lower down and one a little bit higher up. Those are the externals, and right here are the internals. So pretty much, if we're trying to really master distillation, it might be better to run a coolant through the distillation column at the top portion to help maximize our distillation process. The condenser is pretty simple. So once the gas has been distilled in our distillation column, it'll flow all the way to the top and it'll reach this condenser. And you can see it at this top picture right here, how it's actually connected to the distillation column. Once it enters that condenser, then it'll pretty much, the water will, or whatever is going through, will cool and turn back into, it'll cool from a gas and turn back into a liquid, and it'll flow into one of our pots. And finally, we have our boiler with our attached lid. So this lid was laser cut at the Innovation Center, and pretty much, as you can see in the first picture, the distillation column fits right onto that lid. We didn't have to do any sealing. We did for the pipe, we just used a little bit of rubber. But for sealing the lid to the boiler, we didn't have to do any sealing for that. We're just assuming that since it's pretty low pressure operation, that it's not gonna, nothing's gonna leak out, and the weight of the distillation column is gonna provide a good enough seal for that lid to the boiler. So this is the boiler. It's just, I can't remember exactly what it's called, but it's just a cooking device that I retrofitted for this project. So pretty much today, I went over my who, what, where, why, and how for this project. I talked about what distillation is, I talked about my still, and I talked about its features. If you have any questions or concerns, please feel free to contact me at my email or my phone number, which are on the slide right here. This concludes my presentation. Thank you.